हेलो। Good morning, all of you. राधे राधे, जय माता दी, जय श्री राम, जय श्री श्याम। सभी को प्यारा सा गुड मॉर्निंग। भाई आज आपको 11th क्लास का प्रोबेबिलिटी का चैप्टर स्टार्ट होने जा रहा है। आज के चैप्टर में आपको सारा बेसिक्स समझाया जाएगा, तो ये क्लास आपके लिए बहुत इम्पोर्टेंट है। आप क्लास में सभी बने रहिएगा। जो भी लोग नए आए वो प्लीज़ लाइव को स्ट्रीम को लाइक कर दें और शेयर करना मत भूलिएगा। चैनल को सब्सक्राइब कर लीजिएगा। थैंक यू सो मच।
Basic concepts of probability. In this module, we will learn some basic concepts of probability. First, let us learn about random experiments. An experiment is called random experiment if it satisfies the following two conditions. That is, 1. It has more than one possible outcome. 2. It is not possible to predict the outcome in advance. Now let us see what are outcomes and sample space.
Good morning, Bahadur.
A possible result of a random experiment is called its outcome. Consider the experiment of rolling a die. The outcomes of this experiment are 1, 2, 3, 4, 5, or 6 if we are interested in the number of dots on the upper face of the die. And the set of outcomes 1, 2, 3, 4, 5, 6 is called the sample space of the experiment. Thus, the set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Sample space is denoted by the symbol S. Each element of the sample space is called a sample point. In other words, each outcome of the random experiment is also called sample point. Let us now take some examples to understand this. Two coins, a 1 rupee coin and a 2 rupee coin, are tossed once. Find a sample space. Now let us try to solve this. Clearly, the coins are distinguishable in the sense that we can speak of the first coin and the second coin. Since either coin can turn up head, H, or tail, T, the possible outcomes may be heads on both coins is equal to H, H is equal to HH. Head on the first coin and tail on the other is equal to H, T is equal to HT. Tail on the first coin and head on the other is equal to T, H is equal to TH. Tail on both the coins is equal to T, T is equal to TT. Thus, the sample space is S is equal to HH, HT, TH, TT. Let us take another example. Find the sample space associated with the experiment of rolling a pair of dice. One is blue and the other red, once. Also, find the number of elements of this sample space. Let us try to solve this. Suppose 1 appears on blue die and 2 on the red die. We denote this outcome by an ordered pair 1, 2. Similarly, if 3 appears on blue die and 5 on red, the outcome is denoted by the ordered pair 3, 5. In general, each outcome can be denoted by the ordered pair x, y, where x is the number appeared on the blue die and y is the number appeared on the red die. Therefore, this sample space is given by S is equal to x, y, such that x is the number on the blue die and y is the number on the red die. The number of elements on this sample space is 6 into 6 is equal to 36, and the sample space is given here as shown.
कहीं कहीं पे आवाज नहीं है, इसमें ऑडियो नहीं है, अपने आप बंद हो जाती है ऑडियो।
Events. In this module, we will learn about events. Consider the experiment of tossing a coin 2 times. An associated sample space is S is equal to HH, HT, TH, TT. Now, suppose we are interested in those outcomes which correspond to the occurrence of exactly one head. We find that HT and TH are the only elements of S corresponding to the occurrence of this happening or event. These two elements form the set E is equal to HT, TH. We know that the set E is a subset of the sample space S. Similarly, we find the following correspondence between events and subsets of S. Here you can see a table that shows the correspondence between the events and the subsets of S. Event is number of tails is exactly 2. Corresponding subset of S is A is equal to TT. Event is number of tails is at least 1. Corresponding subset of S will be B is equal to HT, TH, TT. Event is number of heads is at most 1. Corresponding subset of S will be C is equal to HT, TH, TT. Second toss is not head. D is equal to HT, TT. Number of tails is at most 2. S is equal to HH, HT, TH, TT. Number of tails is more than 2. Phi, that is nil. The above discussion suggests that a subset of sample space is associated with an event and an event is associated with a subset of sample space. Now we are in a position to define an event. So, by definition, any subset E of a sample space S is called an event. Next, let us see what is the meaning of occurrence of an event. Consider the experiment of throwing a dice. Let E denotes the event a number less than 4 appears. If actually 1 had appeared on the dice, then we say that event E has occurred. As a matter of fact, if outcomes are 2 or 3, we say that event E has occurred. Thus, the event E of a sample space S is said to have occurred if the outcome omega of the experiment is such that omega belongs to E. If the outcome omega is such that omega does not belong to E, we say that the event E has not occurred.
Now types of events.
Types of events. In this module, we will learn about types of an event. First type of events that we will study is impossible and sure events. Empty set phi is called an impossible event and set S, that is, the whole sample space is called the sure event. So, an impossible event is represented by set phi. Since set phi has no events, hence this situation will never happen. And the sure event is represented by the whole set S that has all the possible events, hence this situation will always happen. To better understand these concepts, let us consider the experiment of rolling a dice. As discussed earlier, the associated sample space is S is equal to 1, 2, 3, 4, 5, 6. Let E be the event. The number appears on the dice is a multiple of 7. Can you write the subset associated with the event E? Clearly, no outcome satisfies the condition given in the event, that is, no element of the sample space ensures the occurrence of the event E. Thus, we can say that the empty set only corresponds to the event E. In other words, we can say that it is impossible to have a multiple of 7 on the upper face of the die. Thus, the event E is equal to 5 is an impossible event. Now let us take up another event F. The number turns up is odd or even. Clearly, F is equal to 1, 2, 3, 4, 5, 6 is equal to S. That is, all outcomes of the experiment ensure the occurrence of the event F. Thus, the event F is equal to S is a sure event. Now let us see what is a simple event. If an event E has only one sample point of a sample space, it is called a simple or elementary event. In a sample space containing n distinct elements, there are exactly n simple events. For example, in the experiment of tossing 2 coins, a sample space is S is equal to HH, HT, TH, TT. There are 4 simple events corresponding to this sample space. These are E1 is equal to HH, E2 is equal to HT, E3 is equal to TH, and E4 is equal to TT. Next, let us see what is a compound event. If an event has more than one sample point, it is called a compound event. For example, in the experiment of tossing a coin thrice, the events E, exactly one head appeared, F, at least one head appeared, G, at most one head appeared, etc., are all compound events. The subsets of S associated with these events are E is equal to HTT, THT, TTH, F is equal to HTT, THT, TTH, HHT, HTH, THH, HHH. G is equal to TTT, THT, HTT, TTH. Each of the above subsets contain more than one sample point, hence they are all compound events. Algebra of events. In this module, let us learn about algebra of events. First, let us learn about complementary event. For every event A, there corresponds another event A complement called the complementary event to A. It is also called the event not A. For example, take the experiment of tossing 3 coins. An associated sample space is S is equal to HHH, HHT, HTH, THH, HTT, THT, TTH, TTT. Let A is equal to HTH, HHT, THH be the event, only one tail appears. Clearly, for the outcome HTT, the event A has not occurred. But we may say that the event not A has occurred. Thus, with every outcome which is not in A, we say that not A occurs. Thus, the complementary event not A to the event A is A complement is equal to HHH, HTT, THT, TTH, TTT, or A complement is equal to omega such that omega belongs to S and omega does not belong to A is equal to S minus A. Next, we will learn about the scenario where we say event A or B. Recall that union of two sets A and B denoted by A union B contains all those elements which are either in A or in B or in both. When the sets A and B are two events associated with a sample space, then A union B is the event either A or B or both. This event A union B is also called A or B. Therefore, event A or B is equal to A union B is equal to omega such that omega belongs to A or omega belongs to B. Now let us learn about the scenario where we say the event A and B. We know that intersection of two sets A intersection B is the set of those elements which are common to both A and B, that is, which belong both to A and B. If A and B are two events, then the set A intersection B denotes the event A and B. Thus, A intersection B is equal to omega, such that omega belongs to A and omega belongs to B. For example, in the experiment of throwing a dice twice, let A be the event, score on the first throw is 6, and B is the event, sum of two scores is at least 11. Then A is equal to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. And B is equal to 5, 6, 6, 5, 6, 6. So A intersection B is equal to 6, 5, 6, 6. Note that the set A intersection B is equal to 6566 may represent the event. The score on the first row is 6 and the sum of the scores is at least 11. Now let us learn about the scenario where we say the event A but not B. A but not B is equal to A minus B is equal to 2. If from the elements of A, we remove the elements of B, we have A minus B is equal to 2. 4 not A is equal to A complement is equal to 1, 4, 6. As A complement is all those elements in the sample space which are not there in A.
तो ये हो गया आपका टाइप्स ऑफ इवेंट के बाद एलजेब्रा ऑफ इवेंट्स। अब म्यूचुअली एक्सक्लूसिव और एग्जॉस्टिव क्या होता है ये समझते हैं।
Mutually exclusive and exhaustive events. In this module, we will learn about mutually exclusive and exhaustive events. First, let us learn about mutually exclusive events. In the experiment of rolling a die, we know that the sample space is S is equal to 1, 2, 3, 4, 5, 6. Consider events A, an odd number appears, and B, an even number appears. You can clearly see that the event A excludes the event B, and vice versa. In other words, there is no outcome which ensures the occurrence of events A and B simultaneously. As outcome of event A will be 1, 3, 5, and that of the event B will be 2, 4, 6. Clearly, A intersection B is equal to 5, that is, A and B are disjoint sets. In general, two events A and B are called mutually exclusive events if the occurrence of any one of them excludes the occurrence of the other event, that is, if they cannot occur simultaneously. In this case, the two events A and B are mutually exclusive events. Again, In the experiment of rolling a die, consider the events. Event A, when an odd number appears, and event B, when a number less than 4 appears. Obviously, event A is equal to 1, 3, 5, and event B is equal to 1, 2, 3. Now, 3 belongs to A as well as 3 belongs to B. Therefore, event A and event B are not mutually exclusive events. Before moving any further, an important remark, that is, simple events of a sample space are always mutually exclusive. Now let us learn about exhaustive events. Consider the experiment of throwing a die. We have S is equal to 1, 2, 3, 4, 5, 6. Let us define the following events. Event A, a number less than 4 appears. Event B, a number greater than 2 but less than 5 appears. And event C, a number greater than 4 appears. Then event A is equal to 1, 2, 3. Event B is equal to 3, 4. And event C is equal to 5, 6. We observe that A union B union C is 1, 2, 3, union 3, 4, union 5, 6, which is nothing but sample space S. Such events A, B, and C are called exhaustive events. That means union of all the exhaustive events gives the sample space. Let us see how exhaustive events are represented symbolically. In general, if E1, E2, exclusive and exhaustive events,